The origination of FIDO gets to looking at the overall stack and trying to build out virtualized infrastructure for NFV and SDN. And I'm sure all of you in the room are probably familiar with the various projects on here, OpenStack, OpenDaylight, OPNFV, and many others. But when we looked at the area of the data plane and data plane services, there were some things in there like DPDK, but there was really nothing from a project standards perspective that worked on an accelerated packet processing solution. And this space is really where the origins of FIDO come from. Cisco had a product they called vector packet processing, which has been around since 2002, I think. So a very, very long time, commercially deployed. And they said, hey, how about we take something like VPP and turn it into an open source project? And out of that, the conversation started. This was in late 2015, the conversation started. And out of that, FIDO was born. The project objectives, first and foremost, were, number one, make it high performance. There have been other solutions out there that weren't high performance, but were open. And those are ones that people had sort of dabbled with and tested, but none of them were good enough or fast enough to commercially deploy and to build a project around. Second thing was modular and extensible. VPP is actually built in a modular structure using graph nodes, and that lets you go and use elements of it you may want to use, but skip elements of it that you're not interested in using yourself. And that modular design also makes it very attractive and flexible for many other people. So that was a second paramount element to things. Of course, we wanted it to be open source. And with open source, we wanted strong open source governance. That led us to go to the Linux Foundation, like many other projects have, and approach them in using some of their governance models for this project as well. And it's also Apache 2 licensed. For interoperable, from the perspective of making sure that many other people and projects can use it, and we'll talk a little bit more about that later on. And the last one, multi-vendor. And multi-vendor from a perspective of while there's 13 or so companies that I'll show you in a minute here that started the project and kicked it off, we want this to be able to be embraced and used by anybody and everybody in the industry, from VNF providers to NFVI providers to service providers and ISVs and everybody else all the way through. So with that in mind, that sort of was the foundational objectives of the project as we move forward to start building out the elements of it, some of the bylaws and guidelines that structure it, the steering committee and other governance aspects and other dimensions like that. From a very basic level, I talked to some of these in the very beginning. The most simplistic level, if you look at the data plane, it's really broken up into three areas. So first and foremost, the foundation for all of this is the Data Plane Development Kit, or DPDK. On top of that comes Cisco's vector packet processing that is actually in the project. DPDK is still a separate standalone project over at dpdk.org, but like several other projects that use DPDK, FIDO is built on top of DPDK. So the next layer for the packet processing and network functions comes from Cisco. As I mentioned, they donated their VPP IP to this project on top of it. And then above that, you have a management agent that I'll talk about in the beginning to connect into other projects as well. When we looked at implementation models, no surprise, it's kind of the trifecta of bare metal hardware implementations, virtual machine implementations, and of course, container implementations. So this was sort of the foundational crux of the project from the onset. We launched the project February 11th of this year. We launched with 13 different member companies in this, and all this information, by the way, you can find at the FD.io website. We had 3 platinum members, Cisco, Intel, and Ericsson, 2 gold members, 6Win and Huawei, and then the balance being silver members in the project as well. Since launching on February 11th, additional projects have been proposed by various groups and people in the community. You can also go to the wiki page, I think it's wiki.fd.io, and read about these sub-projects as well. Just a quick overview of them. I've already talked about VPP as one of the foundational projects from the very beginning. The second thing, the continuous system integration and testing, or CSIT. I talked earlier about how one of the first primary objectives was high performance. To make sure that that performance is never lost, we're using a continuous integration model for the project, of which we're constantly testing any and all software additions to the project on known hardware platforms. We're using a lab that the Linux Foundation has for the continuous integration testing. I believe it's located actually in Montreal from a physical space perspective, not that it matters. But again, this is another one of the core elements to make sure we never lose the performance advantage that we're trying to build out through this project. The third one is the honeycomb agent. This is designed to connect up between the FDio project and OpenDaylight. That was something that was recognized very early on as another requirement to let people have the ability to use the performance advantages and networking advantages around FDio. The next one that came up is NSA-based service function chaining. This is another project that got a lot of discussion actually early on and has since formed, I think it was 4 or 6 weeks ago. Joel, do you remember when NSH?
I believe it's 4 weeks.
4 weeks ago.
Officially approved by the TSC 4 weeks ago, I believe.
Okay. And then Overlay Network Engine, that was a much newer one, isn't it? A couple weeks ago?
It was approved at the same time, actually.
Okay, same time. Okay. Transport Layer Development Kit, this is not approved yet, and this is something that's designed to build out library functions and or perhaps a complete host user space stack. So if anyone's interested in this aspect of things, feel free to go look at the wiki page, chime in with comments, feedback, or if you're interested in getting involved in it, we welcome you there as well. And the last one here is fast data stacks. Fast data stacks is not within FDio itself, but actually is within OPNFV, and it's designed to be able to use the vSwitch functionality, forwarding functionality from FDio plugged into an OPNFV environment. So that's where you start seeing some of the interconnections between different projects. So we've already talked about the honeycomb agent connecting in ODL. Here's another agent or an element connecting into OPNFV. And as FDio develops further in the future here, I expect to see more and more connections like that. What I'd like to do now is just jump into a couple of questions. And Lauren, I'd like to start with you. Can you talk to us a little bit about Cisco's thoughts around VPP when they first catalyzed this idea in 2015 around open sourcing VPP and what they hope to kind of create and change in the industry?
You know, VPP's been around since 2002. Dave Barrick is the engineer, the lead engineer that actually put it out. You can follow him on Twitter at VPP Guy and learn more about it from there. You know, I think from our perspective, what we were looking at was a lot of the web scale companies and the way that they actually do development is focused on DevOps, performance, scalability, and the ability to move things very, very quickly. And as we looked at VPP and not only the reliability, but also the high performance that it was able to deliver, we thought that it was beneficial to the community, to our customers, and that's why we decided to open source it. Ultimately, we wanted to move the industry forward, and we wanted to build a collective group of folks that wanted to join us.
Okay, interesting. Eric, I know you were some of the first people. Sixwin was one of the first companies that I think Cisco and Intel and others talked to. There's a connection here between FDio and DPDK. Can you share with us kind of your views as to how you see that fitting in with the work Sixwin's been doing around DPDK for a very long time now, and how FDio kind of fits on top of that and complements it?
So first of all, we were very happy to see this initiative from Cisco, because we have been working on that topic for years, sometime in the desert also, you know, saying that performance is going to be a key technology for transforming the industry towards NFV and SDN. So we have been working on this for a long time. So as you know, so we will analyze, in fact, all the different bottlenecks in the architecture, and so we have been working with Intel on the DPDK, because it was absolutely the necessary foundation to make it work, because you have to send and receive packet very efficiently. And so I think we did a pretty good job, you know, with all the industry because in a certain way, these standards are a little bit a tower of Babel in a certain way. So we started by the foundation, and now with DPDK, we have really an industry standard on top of which the industry can build different projects. So I do not remember exactly, but I think around 20 projects now are built on top of DPDK, so that's very good. And of course, we see with great interest, in fact, you have FDio being built on DPDK, because I think it's really the right way to do things. And so I think we are also well positioned, I would say, at the boundary between DPDK and FDio to help understand the requirement from the application to make DPDK better. And so we are really proud to do this.
Joel, I know Ericsson and Cisco announced a collaboration many months ago. I think it was towards the end of 2015. And Ericsson joined this as a platinum member. I know you've done a lot of work in this space. Can you sort of share with us your vision as to how FDio fits in with all the other projects and all the other standards works that people are doing as NFV and other network transformation rolls out?
Let's be clear. We're participating in this because Ericsson thinks it's useful. We're not just doing favors for partners. This looks like it has the potential to be an extremely powerful project. There is the performance aspect, which everybody starts from. But that's actually arguably less important to us because we have solutions that perform well enough for our customers right now. But the flexibility and deployability of this solution enables us to add new features like the service function chaining, which is very important to lots of initiatives in Ericsson. We want common, strong support for that. This enables it. It also enables network functions to make use of very high-performance data plane forwarding without having to rebuild that every time you build a function, and to use common interfaces, for example, for packet metadata. So we're investigating this through a very wide range of capabilities. So it's very important to us, for example, that it be usable, honeycomb, and that it be able to support service chaining. So those are where we're putting our initial energy, but the whole spectrum and the vast array of capabilities, the transport development kit looks like it'll be very interesting for a lot of people. So it's got potential, and we're hoping with some more people involved, with more members, this will become a way to take the industry forward in this whole data plane space, which there's only been one project so far, and industry needs more than one alternative.
Jim, since I think the slide that needs to be up here right now, other than our beautiful faces, is probably the architecture one, if you can go back a couple slides. So when we actually talk about this and how it fits into the Uber architecture and why we're doing things along these lines, I think this is really important to take a look at and have everyone really understand what the open networking stack looks like and what we're trying to enable up stack further. Is that fair? Great.
Sanjay, I know from a Red Hat perspective, Red Hat's been involved in a lot of activity like this. Sometime last year, they bolted DPDK into Red Hat Enterprise Linux, I believe 7.1. I think they're supporting and including OVS and others. Can you talk a little bit about both how you see FDio fitting into that, and can you also comment a little bit on additional needs that you can sort of foresee that you're hoping the community works on and builds out?
DPDK support is there, and that's something that I think everyone's been looking forward to. But as we move towards what's needed to be successful, to be really successful in NFV deployment, what we're seeing is a little bit about, referring back to what Joel was talking about, there needs to be a way to orchestrate from the OpenStack layer the functions that that a customer wants to deploy. So it's as more and more innovation comes into FDio, for example, those additional functions need to be available and orchestratable from the higher layers. And there's work going on in OpenDaylight, as you can see, and we're a big contributor to OpenDaylight. There's also work that has to go on in OpenStack, in Neutron, to make that actually usable to the end user. That's really where this whole orchestration stack has to be thought through and put together, not just through API mechanisms, but also through the semantics of what it means when you create a new function at the OpenStack layer, how to bring it all the way down to the FDio layer.
Yunsong, Huawei is also a strong supporter of the project as well. Where do you see Huawei's interest in FDio, and how does it fit in with Huawei's overall cloud, NFV, and SDN strategy?
Huawei has been really active participants in open source communities, right? Actually, here we have been building different projects, open source projects, under Linux Foundation. With Intel and Cisco, we have built I/O Visor in kernel, right? So now this is in userland. For us, we believe that we should really make it possible that our customers can get different technical solutions, right? Today, the kernel, Linux kernel has a lot of drivers, but the performance is not that good. Well, that's the reason we have been talking with Intel to push to make DPDK the primary I/O framework in user land since 2011. Right? Finally, the FDIO is there. Right? I believe this is really great because we will certainly leverage this technology in our solutions. For example, our virtual switch, EVS, Elastic Virtual Switch, can have its data plane in user space. We have used DPDK as the I/O framework in user space and delivered that to certain customers. In the future, we believe in this community we can do a lot more. Firstly, the I/O. We want to make this really an alternative to kernel. Of course, we are partnering with Intel, Red Hat, and a lot of other companies to improve the driver performance in kernel as well. Right? Also, but we certainly want to make this a good alternative. Then in VPP, I'm not sure what we can do with VPP today, but we are putting our resources to make sure we can contribute to this community and to make sure our customers can really benefit from this open source initiative. Right? Other things, we have been working together with all those partners on a lot of other things, from testing, from OpenDaylight, everything. I believe we are not competitors within community. Actually, we are all partners.
Okay.
Thank you.
Interesting. Yes, so you mentioned one other thing. So I didn't mention it earlier, but FDio is a user space activity. But Yunsong, you just mentioned the kernel aspect of things. Maybe a question for anybody in the panel. Do you see a need for someone to do kernel optimization similar, or do you think that the industry's largely decided that we're going to move performance into user space? Any views from the panelists?
As you said, performance is important, but also integration in the system is also very important. So at 6WINS, there is no secret about this. So we have already our own data plane solution based on OVS, and as a golden rule in our design, I would say we put a lot of efforts on what we call resynchronizing the data plane stack with the Linux kernel. In fact, so don't do optimization in the Linux kernel, but use it to be synchronized with what we do. So it's a first approach. The benefits is the integration with the system is much easier. On the other side, and that's also a perfect approach, you have this standalone stack, which is you redo everything in, I would say, beside the kernel. And so the problem you may have is that you have to integrate everything with the control plane, with the management plane, and so on. So there are different use cases. Some of them are probably well suited for the first one, and others may take benefits for probably a little bit more performance on the second one. And that's clearly what we joined this group, because we think that we have to provide our customer with the right solution. What is true today may not be true tomorrow. And we have also to help our customer to have a kind of vision and a path from a solution that is deployable today, and maybe a solution that is going to be deployed in a few months, years, and so on. So I think it's important. So we are not really in favor of Linux optimization in a certain way. We prefer to do how we do, but that's could be a debate.
Joel has something to add, I think.
So while I'm never one to complain about the kernel getting faster, our use cases generally we found, I started out assuming that we needed to do everything in the kernel to get the performance. And what we're finding is that it's actually more important and quite practical to do it in user space. Okay. And it gets around the problem that in a cloud environment, you can't adjust the kernel for each application. You've got to have a common kernel that's widely deployed, and then the applications have to get the data plane throughput to support the specific application. So the fact that FDio is very data plane oriented is actually important to us, and we think very important to the end users.
I would say that, with all the excitement, I mean, we shouldn't minimize the importance of the kernel. It's, the vast majority of Linux users out there are using the networking in the kernel. Yep. So as we find use cases that are generally applicable, I would see that the Linux community would work towards having, and as they have over many, many years, improving the kernel. Where user space comes into play is when you have very specific requirements that are not generally applicable across the entire IT industry, and not even telco industry, but the IT industry. Then, like, there are very specific protocols in the telco industry that are not generally used. You don't want to have to modify the kernel to support those things. So that's where there's a distinction.
One of the other things I heard several of you mention was the topic of a virtual switch. There's lots of virtual switches out there today. OVS is an open source one. There's commercial virtual switches available as well, and then FDio brings yet another virtual switch into the mix. I'd like to hear some comments as to how people see that playing out. Is it an additional option for the industry? Do you think that things like FDio might sort of take a lead role and become a open source virtual switch of choice, or do you think there will always be a role for commercial virtual switches? Someone like to comment sort of on views around these switches there? Eric, I know you you guys have Virtual Accelerator, which is a high-performance virtual switch that Six1's selling. You're also involved, I know, in this project, and OVS you guys keep monitoring. Can you provide some comments on that a little bit, perhaps?
Yes, there is a virtual switch. That's obviously a key element of the architecture. What is also important is the ability to bring more networking features. So if you take the NFVI, the NFV infrastructure, so of course the core is the virtual switch. But we see more and more needs for additional capabilities. So I think FDio has been built to be more than a virtual switch by essence, I would say. And so I tend to think that if the virtual switch functions have to be extended, so FDio may be better suited to do that. That's because again, I don't want to talk too much about Six1, although we are the less known company in this panel, so and the smallest. But what we do is when we accelerate the virtual switch, we don't use OVS DPDK. We accelerate all the functions from Linux, including the OVS. And we have our own stack on DPDK, which is but because I definitely think that we need to build virtual switch-based system, having in mind you will have to add routing, you will have to add NAT, IPsec, maybe TCP offload, and so on at this level. So we need to have something that has been designed having this in mind.
We believe that open source is really not competing with commercial products, right? We believe Open vSwitch has been really great, but VMware is not using it in their own solution, right? It's not, when we talk about open source, it's not only about to open source the code, it's about open governing, right? Actually, FDio is a good model because people are talking about the future of the technology. But on open source software that's controlled by one party or a few parties, we don't think that's the best solution for our customers. That's the reason we have been talking with Intel to make DPDK really an open community inside of open source only product. That's really the importance of the beauty of open source communities, right? That's the thing. So for Huawei, we do have open source based solutions like Open vSwitch based solutions for our customers. Also, we do provide our commercial version, which is compatible with Open vSwitch, but with more features and more higher performance. Also, just to mention a little bit about acceleration. We believe there are two ways to do acceleration. One way is to do software acceleration. Basically, people call it bypass. You bypass kernel, do a lot of things, remove some features to have better performance. That's called software acceleration. We also do hardware acceleration. That we also partnered with Intel, Xilinx, Broadcom, a lot of hardware vendors. We use their hardware to do more on hardware to accelerate the whole virtual switch instead of doing everything in software. That's what our vision and what we are doing with virtual switch.
One of the other things about open source communities, especially when they start, is getting them off the ground and running. I'd like Lauren to comment a little bit on sort of how you build a community and your thoughts and ideas here. You know, Cisco hosted a training event before the project launched in January, and then they hosted another one here in the Bay Area last week that I believe was completely sold out, and there's strong interest for more. The traffic on the developer mailing list has grown pretty significantly from a lot of different people trying out FIDO and trying out VPP themselves and trying to get there. Lauren, can you share a little bit of your thoughts and ideas of how we can grow this community, things we need to do next, how to get more people engaged, et cetera?
Yeah, and I think the key here is really that you build a community, you don't launch one. And so whereas initially sometimes it takes, monetary stuff to get off the ground, that's not always the case. Excuse me. There's been, I believe, over 500 commits to this project already, which is huge.
2 months.
And
right.
some of the stuff that we're really looking forward to is integration into OpenStack, into OpenDaylight. Also, we are looking at container-based development with VPP and also looking at microservices and how that comes into play too. So we're looking a little bit further up the stack. And as we move forward, there's definitely going to be more trainings, more development. The best way to get involved is to get on the mailing list, get online and just sign up and start hitting that list. And also, if you're interested in participating, talk to any of us after the session as well, and we can point you in the right direction.
You saw the list of projects, and there are a number of projects. There are more projects coming. We've gotten the first haul, the first surge. These are projects like the NSH project and the Honeycomb project, which we knew even at launch these were going to be important projects. TLDK is the first of the new round, as is ONE. We're going to have more projects. There are mailing lists for each project. There's a mailing list for the whole thing. At the moment, actually, the biggest discussion is the build broke again. What do you know? This is what happens with projects. Right. We've got more people doing things, more people stressing things. Things break, then the infrastructure guys fix it, and we keep moving forward. There's a lot of work on taking VPP. VPP was built by Cisco very nicely, but it's built as an integrated thing. Now we have to take some of those pieces. For example, the guys who did the code for NSH did it in VPP because that's where they could do it. Now we're creating a freestanding project. We're doing the work to make that separate. ONE is probably going to borrow from some of the Lisp work we've done in ODL. There's a lot of work going on. Let me see what else. To give you an idea, you talked about hardware acceleration. At least one project has been suggested, isn't yet at the formation stage, for figuring out how you use the whole architecture of FIDO when you're going to deliver it on a hardware platform. That's actually very interesting. On the other extreme, we have some guys who are saying, we need to deliver this on a 32-bit general purpose processor. So we're covering the whole range. And if you see any uses for this kind of stack, come on the main list, discuss project ideas. We'd love to have more ideas. I would love to be in the situation where the technical committee has more ideas to entertain than we have time. We're not even close. Right. We have time to discuss this stuff with you, and we'd love to see it moving forward.
Yeah, the 32-bit project was interesting. I think it started from a guy saying, hey, can I run this on a Raspberry Pi? And then it just took off from there, right? It's just very interesting. The other thing, if you go to fd.io, you'll see just below, I think, the top navigation, a button that says download the code here, right? That was added, I think, after some feedback from the community of which tab do I go to find the code itself, right? So we've tried to make that a lot easier for developers to go and figure that out, so thank you. Any questions from the audience? Yes?
VPP was conceived 10 years ago. There was no NFV then, there was no virtualization then. So now, with FDIO, we are trying to piggyback on NFV and OPNFV, and I wonder what need to change to make it NFV-ish. The second question, we talk about hardware acceleration. In addition to DPDK, there is something called ODP, the Open Data Plane, for SoCs, mostly on the ARM side. Do we see any room for ODP in these projects? Thanks.
Anyone like to take those on?
Well, I can say that on the second question, on the question of do we see room for ODP, while I can't address ODP specifically, I do know that there has been multiple rounds of discussion of supporting other hardware interface mechanisms, making it agnostic so that it works well with DPDK. We want that, but that it can work with other people's hardware as well. So that if there's people who are interested, the real answer to all these questions is if you want to see it happen, come, because this is something that's discussed, but I haven't seen enough people to create a project yet to do that kind of thing. If people show up and want to do it, it clearly fits within the charter, and we're happy to do that. As for virtualization, since it was built as a software stack, although it was built for use in hardware environments as well, it fits very well in microservice, containerized, or virtual machine environments. It's actually a surprisingly good fit for the modern environment. Somebody pointed out to me that while Cisco started this quite a long time ago, it was actually a very small team for a long time. I think this is one of these events where it's now railroading time, and it's going to be much more important now than it was when it was started.
Yeah, I would say that, the code is extremely portable, obviously, but it's also been rewritten 3 times. And in that essence, obviously as the industry has evolved, we've evolved with it. And, I think the portability of that is really one of the things that we've focused on, as well as, we're committing to, having this be in the user space and also highly performant, and looking at what a lot of the web scale companies are doing and trying to help the rest of the ecosystem move in that direction as well.
So first of all, it's interesting to see that in the members, correct me if I'm wrong, there is Cavium, and Cavium has ARM-based processors, so it would be interesting to know what they think about it. This said, the DPDK has also been ported on ARM, so it's and one day or another, I think we want. I was talking about the Tower of Babel of standards, so I think one day or another, so we have to decide if we want to have one or two. So that's the first point. Secondly, I fully agree with what you were saying before. So regarding the software, really software-based solutions. So the beauty is that it's of course it's easier to start with bare metal and to move to virtualization and so on. I think we come back to the question, and I think you already said that VPP has been developed by Cisco to be integrated in the Cisco environment. So now I think we have to work together to make this, I would say, more open, and how it can be integrated in a complex environment like NFV and so on. So we come back to the OpenDaylight, to the OpenStack and so on. So that's, but I think the basics are really good, and the beauty of software. So we are. Right. We are fully convinced by that, is that you benefit from so many things that, when we started with 6-wing gate, I do not remember what was the frequency of the Intel processor and the number of cores. Right. So now, we've probably multiplied the performance by several X, and so it still works, and if the software is well designed, so you benefit from this. So that's very, very, very clear.
Right. The other thing I'll point out, if it's not well known, is that VPP runs on multiple architectures today. It runs on Intel architecture, ARM, and Power.
When we talk about NFV, right, it's virtualization. Basically, a lot of people are talking about NFV just to virtualize the existing boxes, the equipments, to virtualize those embedded softwares and the systems. But to us, and because we have heard a lot from our customers, we believe NFV should move to cloud. That's the thing. There are 2 major factors missing from current implementations of NFVs, not about this project, but the overall NFV architecture. One is it must be scalable across the cluster. It should be cloud-based instead of virtual machine-based. That's extremely important. That's also one reason we are participating in this community. We really want to bring those ideas, those customer requirements to the community, so that we don't really just repeat to build everything which was on hardware as embedded software to a virtual machine or to a container to just pack those existing things. We really want to re-architect the whole NFV infrastructure and the things to give the greater value to our customers. That's the major thing we are here participating the community. I believe that will really benefit everyone. The second thing is it should be hardware agnostic. Firstly, of course, there are different, people mentioned there are 32-bit system, there are 64-bit system. Also, there are a lot of multi-cores, FPGA, a lot of things. We want to make sure the hardware, all the hardware can be utilized. For example, VPP was running on Cisco's NP, and today we really want to make sure the whole thing can be running on FPGA, NP, and some SMP other architectures. That's my 2 cents. Thank you.
When do you think this will be in the market? When will it be deployed? Be able to say, there it is, what we're doing is now in deployment.
Well, VPP element has been deployed by Cisco for a very long time. I don't know if there's a Cisco transition from VPP to FIDO. It's one and the same now.
We are using it. Certain customers are using it today. It is in products that we do have. And we are looking at extending it into the community as well. I don't know, is the code drop date public for, okay. I cannot comment further on that right now.
So it was a good question.
It was a great question. But there are plans. Let's just, obviously, there is a date.
Join the developer list
that is
and
coming
keep an
soon.
eye open, right?
That is coming soon.
Okay.
I'll leave that there.
How you would see applications or VNFs being using VPP? How the integration may look like, and how the design of VNF using VPP may look like, and the deployment models. So it's like a more generic question, not just what VPP does, but how it fits into the whole solution.
From a bigger stack perspective, you mean? Okay.
I mean, this is one example of how you could fit a function into a larger deployment, because absolutely, when you really put this out in the real world, you're going to need to orchestrate all the different VNFs. The way to think about a VNF is really, you have to think about it a little bit differently than the way they've been deployed currently, because a lot of times today you're seeing VNFs deployed as virtual machines, as individual virtual machines. But the original concept of VNF, people saw the word virtual and they thought virtual meant virtual machine. Well, it just means a virtual in the general sense that it's a function. It's a function that has to happen somewhere, and it's an abstract function. And whether that function occurs, in hardware, in a container, in a virtual machine, it really doesn't matter. It's that the function is, it's a function constrained to, say, one tenant or one piece of a service chain or whatever it is. As long as that piece can be orchestrated and fit into the overall picture, then it can work in an NFV environment. So in this diagram, it's really the VPP plugins, the different functions that are being placed in FIDO. Those are the pieces that would construct the functions.
Thank you. Just stepping back a little bit, I'm just getting started with all of this stuff myself. So other than this is going to be the fastest data plane in the universe, can you guys explain what problem are we really solving here with FIDO, and how do you prove that you're going to solve it in, let's say, a year or 2 years from now?
Joel, Eric, either one?
So let's start. So being the fastest networking software in the world is nice. So when we are talking about NFV, so whatever the solution might be, you have performance bottleneck in 2 areas. The first one is at the hypervisor level, because if you want to provide the right aggregate traffic to the different VNFs, so you have the bottleneck at the virtual switch level and maybe more. Okay, so it's a way, in fact, to have an efficient NFV infrastructure first. Then, and we come back also to the previous question, you have the VNF. So clearly today, I would say standard VNFs that are developed to scale very well on multi-core processors and so on won't scale. because you have a problem of communication between the VNF and the virtual switch, and that's where if you develop a VNF based on DPDK, the performance will be better. And then if you use FIDO or another fastpass solution, you can increase the performance of your individual data plane of your VNF. So having a very efficient, that's why we say, and we have been saying this for a long time, if you want to have really a real deployment of NFV with the right level of performance, you have to solve these two performance bottlenecks. And so that's the problem we want to solve with this, with FIDO, maybe with a solution, but obviously with FIDO. And what is also very important, if you are being to be very efficient, what does it mean? You need very few processing resources for networking. And so on your server, you save a lot of resources to implement applications. So it's also a way, improving performance is also another way to say you are going to improve your VNF density. And so you have better system, you save CapEx, and you benefit from the virtualization for improving your OpEx and so on. So that's really, we solve a business problem. We are not solving just a problem of gigabits or terabits or whatever.
I guess I would put it slightly differently. I agree with Eric, but I want to answer your question from a different perspective. I'm an engineer. I'm not religious about these technologies. I can't promise you that in 2 years it's going to be the greatest thing since sliced bread. What I can say right now is that it shows the potential to enhance the flexibility of the applications, the performance of the applications, and the ability to build virtual switches of various kinds that meet real needs of customers. That's potential. We as a community have to demonstrate that potential to you as an end user. And the best way to do that is to get involved. I mean, there are some interesting ideas. Some of the folks have suggested that this can really improve the performance of storage networking. I don't even know enough about storage networking to know how that'll be the case, but they tell me it looks like it's relevant. Okay, let's see, let's try it. Right. Because this is the graph structure as well as the vector processing combined to make a very powerful tool we can use to address a range of needs. And we want to see what works.
The question earlier on, fastest data plane solution ever, right? I mean, whoever's going to have the fastest today won't be the fastest tomorrow, but I think it'll be a combination of what builds enough community momentum behind it and what resonates in the industry as useful and valuable in providing benefits and features needed. I think Joel started out at the very beginning when I mentioned high performance element, mentioning that there's more than just performance, right? There's lots of other services and functions and features and capabilities. There's connections to other projects to build up the whole cloud stack. All those things I think will play an element to it. I think there were some hands up in this side of the room for questions earlier.
With this virtualization, basically, we're kind of moving away from hardware-specific type solutions. Do you see the interface technology, like, we have interfaces that are 10 gig, 40 gig, 100 gig, 400 gig, and beyond. How would that increase in speed would affect this virtualization scheme altogether? I mean, could it basically obsolete it, or, those kind of things?
The proverbial increasing traffic, right? Yeah. So 1 gig, 10 gig, 40 gig, 100 gig, and beyond.
Actually, as I mentioned earlier, we mentioned the scalability just because of this, right? Today, you may have 10 gig NIC or 40 gig NIC. Basically, you have some very simple applications, just a few applications running there. Then, okay, you get one core or a few cores to drive. You can just use up the whole bandwidth. But when you really get multiple 40 gig interfaces, also you get 100 gig network, you need a lot more cores, right? You cannot limit to one CPU cores. Certainly the scalability in the system is extremely important. Also, there will be a lot of low power solutions. You really want to scale the whole solution to multiple nodes as a cluster. That's also very important. We believe this community should move to the direction to bridge the cloud technology with NFV, not to create silos. But today, personally, I don't have enough understanding about VPP, but we are learning that. But certainly, we'll bring in all our observations our ideas and our requirements from customers to the community.
Yes, so there was always a balance, between software and hardware, so between cloud and servers. So it's very sure that today we have a very software-oriented positioning, okay? But you're right that with the high-speed Ethernet that is going to come, 100 gig and so on, so NICs are going to be more and more, are going to be smarter and smarter. So we have the concept of the smart NIC, which is in fact you have a processor on the NIC itself that could implement some capabilities. And by the way, FIDO is software, so the software can run either on the server or on the smart NIC. So it's very clear that with the bandwidth we are going to manage, there will be a need to a kind of some hardware offloads for, I would say, quite static information in the network. But as soon as it will become very dynamic and so on, we will need to have software. So I think this has a kind of evolution. So today there is APIs directly on top of software. So maybe these APIs will have to evolve a little bit to be able to interface some pieces of initially done in software to be done on hardware. So it means that maybe FIDO will have to open a few APIs to make it work better with the hardware. So I don't see a complete change of the architecture. But we will have to probably work on very precise points to take benefit of the latest hardware improvements. We will have to certainly in the coming years, months, years, or more.
Yeah, I think if we've learned anything across multitude of projects is that you need an element of scalability. If you don't have it, you're going to run out of speed in some X generations. So the more you build it in, the better. But also to Joel's point, we won't know what problems are going to come when you do multi-100 gig, 400 gig implementations. So we'll set a course for that and tackle it when it gets here.
Yeah, so this is a concept. You have the fast pass. You may have a ultra fast pass interface with the fast pass in software. So we may have different tiers in the architecture to make it work better.
Question, VNF design. Would you see VNFs being deployed as plugins to VPP as a viable option? Say, if you have a VPP installed on any server and then you distribute your VNF as a plugin to VPP, which contains both netconf interfaces, command line interface, and the data plane interface in one bundle. In theory, you can do that, but do you think this would be something useful, or it would be like VPP as a vSwitch and VNF which use VPP running on top of that? Which one you think would work?
So you're getting to an important point of orchestration again. This will require, Jim had asked, where does the additional work need to be done? There's a lot of really interesting projects here. A lot of them are data path projects. There needs to be some work done on orchestration to handle the case you're talking about, because there are security aspects of like distributing plug-in all over the place. How do you manage that properly? How do you manage versioning of all of these different components? It's a really, really important topic, and I think to get NFV deployment successful with this technology, that aspect needs to be addressed.
All right, one question with this lady in the back.
So I have two questions. One is do you see it as a competitor for Open vSwitch, or would it complement Open vSwitch? My second question is, if tomorrow somebody says, I'm going to implement, I don't know, whatever layer 2 protocol which doesn't use MAC or whatever, and it creates some new nodes and graphs in VPP. So I understand that FIDO has a history from VPP and it has all that implementation, right? So does it bypass all of that, or does it sit on top of it? How does that work?
So 2 parts, comment on comparison OVS and comment on layer 2.
So if anybody defines a new protocol, is there an overhead of the existing protocol using VPP, or it can bypass all of that and you have a new path which the data goes through?
So the whole point of the graph is that you can put modules in at the right places. So if you want a new handler of packets right off of what we would call the Ethernet, you can put one there. If you want a new packet, a new handler for the packet carried over the Ethernet, you can do that. I tend to think that we're going to find most of the usage is Ethernet and IP, but you can, if you have special uses, plug those in, and the path will still be fast. You just have to make sure you write the new plugins as efficiently as the old ones have been written if you want the same performance. So you don't pay a performance penalty for doing new things using the VPP structure. In fact, it's rather the opposite. It very naturally allows us to put new things either at the ends, new protocols on the wire, or in the middle, new things like NSH, GPE, VXLAN, all the other overlays, ONE, that everybody's continually inventing. We forever in the IETF bemoan the number of tunnel protocols and then invent 3 more. So the ability to support all of these is actually very important.
And your other question, I think, was comparison to OVS. I will say, and maybe Lauren can comment on this one, there was a comparison done by the European Advanced Networking Technology Center, EANTC, and I think it was sometime in Q4 of last year, looking at VPP versus OVS. And I won't speak for the data, but you can go do a search on that and look at the performance results if you want. I don't know if anyone from the panel have any comments on, again, it's not just performance, there's also the feature elements, and there's what are you looking for in your usage model for, which is the better vSwitch for you, right? I think that's an open-ended question. Anyone offer any comments around that?
I will just say that our users and our customers and also our company needed code that would work with the larger stack.
I think we're about out of time, so I'd like to thank Yunsong, Sanjay, Lauren, Eric, and Joel for their time in the panel today. Thank you, guys.